Today we are going to get some starting knowledge before designing any kind of the filter circuit with the help of inverting terminal of op amp. So basically any kind of the filter circuit can be designed either with the help of inverting terminal of op amp or with the help of non-inverting terminal of op amp. That means either with the help of negative terminal of operational amplifier or with the help of this positive terminal of operational amplifier. So if the input signal is to be given at negative terminal of operational amplifier, that is called as designing by inverting terminal of operational amplifier circuit. And if this input signal is to be given positive terminal of operational amplifier, then that kind of filter designing circuit is called as non-inverting type of filter design with the help of operational amplifier circuit. So here we are interested to design the filter circuit with the help of inverting terminal of op amp. So the transfer function of inverting terminal of op amp is represented as Z2 by Z1, where Z2 and Z1 is nothing but the combination of resistor and capacitor, where Z2 can be written as R2 plus C2 and Z1 can be written as R1 plus C1, where Z2 is the feedback element which is connected in between output to input terminal of the operational amplifier, and Z1 is the input connection which is connected at input terminal of operational amplifier circuit. Basically for the design of filter circuit only we are using resistor and capacitor for the design. One more element is there which is called as the inductor, but for the design of any kind of the filter circuit, in most of the cases in general we are not using the inductor. What is the reason behind that? Inductor is having the high losses in any kind of the circuit. So if losses would be generated, then on that condition it would not be feasible to use the inductor. That's why in most of the cases only we use resistor and capacitor for the design of the filter circuit. So here the value of Z2, as I mentioned here, R2 and C2, the combination of R2 and C2. Similarly the value of Z1 as R1 and C1. Now this circuit can be designed either the series combination or with the help of parallel combination. Series combination, that means this resistor and capacitor will be connected in series. That means in the form of R and C. But if we talk about the parallel combination, then the connection of resistor and capacitor would be in parallel. So both the components would be connected in parallel. So here we are having the two options. Either we can connect the circuit in the form of series combination of resistor and capacitor, or we can connect the circuit in the form of parallel combination of resistor and capacitor. So any of the combination we can use for the final design of the filter. We are free to choose any kind of the designing. So if suppose we are concentrating on series combination of filter design circuit, then the connection will be resistor and capacitor will be connected in series, and in mathematical form the value of that series combination, that would be represented here by Z. So Z will be equal to R plus 1 by Cs. So the final value of Z in series combination will be equal to R plus 1 by Cs. Based on the feedback connection or the input connection, it can be represented either by R2 plus 1 by C2s or R1 plus 1 by C1s. If that is connected in input, that means if we are talking about Z1, then the final value will be R1 plus 1 by C1s, and if we are talking about Z2, then that would be R2 plus 1 by C2s. So these are some connection of the inverting terminal of operational amplifier in series connection. Now if we talk about the parallel combination, then the circuit can be connected, or circuit must be connected in parallel form, and in parallel form the value of Z will be equal to R in parallel with CS. And if I go to solve this particular expression, then the value of Z is equal to R into 1 by CS divided by R plus 1 by CS. And after some simplification, the final value of Z would be 1 by CS plus 1 by R. This is the final value of Z. Why I am mostly concentrating on these formulas? Why? Because when we go for the final designing of any kind of the filter circuit, we directly compare the transfer function with these two equations. That's why these equation number 1 and equation number 2 are compulsory. So whenever we are interested to design the filter circuit with the help of series combination, we need to compare the transfer function equation with equation number 1, R plus 1 by CS. And if we are designing the circuit with parallel combination, then on that condition we need to compare that transfer function with this equation number 2, which is 1 by CS plus 1 by R. Now if in the transfer function both resistors and capacitors are present, that means Z1 is also having R and C, Z2 is also having R and C. Then on that condition, if we are designing circuit by series combination, the final circuit would be like that. That means in Z1 this R1 and C1 would be connected in series, and in Z2 R2 and C2 will be connected in series. And if, because here we are mostly talking about the inverting terminal of op-amp, that's why the value of Z will be equal to, Z2 is equal to R2 plus 1 by C2S from equation number 1, this one. So from equation number 1 already we have calculated in series combination what would be the value of Z. So Z is equal to R plus 1 by CS. With the same fundamental, we have calculated here the value of Z2 is R2 plus 1 by C2S. Similarly, for this Z1, the value of Z1 will be R1 plus 1 by C1S. So these are the final values of the Z1 and Z2. These values are also important because when we go to solve the problem, we directly compare the final result with these equations. Now similarly in parallel combination, these resistors and capacitors are connected in parallel. So Z2 is equal to how much? 1 by C2S plus 1 by R2, which is based on this equation number 2. Already we had seen how to calculate the value of Z. So but from equation number 2 the value of Z was 1 by CS plus 1 by R. So with the help of same fundamental, what is the value of Z2? Z2 is equal to 1 by C2S plus 1 by R2. Similarly, the value of Z1 would be 1 by C1S plus 1 by R1. So these are my final expressions whenever the circuit would be connected in series or in parallel. And with the help of this fundamental, in our next video we will see some problems how can we implement the filter circuit based on the inverting terminal of op-amp connection. Either that filter circuit would be in series combination or that filter circuit would be connected in parallel combination. So in next problem we will see the implementation of these circuit with the help of some problems. Thank you.